Welcome to this video lecture. See, till now in control systems chapters we have studied about how to design and how to get the transfer function of a given control system, and from the given transfer function, root locus, Bode plot, Nyquist plot, RH criteria, many techniques we have used, and all these techniques requires transfer function to solve. And using transfer function we have identified whether the system is stable or unstable, and we have even designed the control system also. So till now whatever we have studied, we have used a transfer function method to design and analyze the given control system. Now let us learn about how to design and analyze the control system using another method called as state space analysis method. Okay, so the first method to design and analyze the control system is transfer function method, which we have studied already. Now the second method to design and analyze control system is state space analysis. Okay, now we will understand what is this state space analysis and what are the different terms used in state space analysis. For that you have to consider you have a simple system called as mass M, a mechanical system. Rollers are there, and then you have a rigid surface, and there is an input force which is pulling towards the right side, this mass. Okay, so because there is a force applied in the right side, even there will be a displacement in the mass towards right side only. So let us call the displacement as y of t. So if the force applied is the input variable, then what will be the displacement of the mass? Because you applied force, you are getting a displacement of the mass. So this displacement can be called as output displacement. Okay, if the force is input, then the displacement y of t is the output of the mechanical system. Now by using mathematical representation, can we write as the force applied u of t is equal to mass m into d square y of t by dt square. You know that for a mass the displacement is nothing but double differentiation of y of t. Okay, this we have studied from your mathematical representation of mechanical system. Force applied u of t is equal to m into d square y of t by dt square. This is for a mass system. Now similarly what we can write? We can write v of t is equal to dy by dt. Correct? No? You know that if you differentiate a displacement, then you are going to get a velocity. So v stands for velocity of a system. Similarly, how to find acceleration of a system? A of t is equal to d square by dt square of y of t. Okay, so if you know this displacement y of t, from that you can calculate velocity v of t, and from that again you can calculate acceleration a of t. Correct? So if you know y of t, you can calculate velocity from that and acceleration from that. So I can call this y of t as a state variable of the system. So what is the meaning of state variable of the system? Y of t, in this example what I have taken, y of t is a state variable. So y of t is a state variable, which is nothing but, if you know the value of this y of t, from that value you can calculate the other values of the system called as v of t, and a of t stands for velocity and acceleration. Correct? No? So this variable y of t is called as state variable. So state variable is defined as the variables whose value if you know, then you can find out the other parameters of the given control system for the future. That is called as state variable. Okay, now what is the meaning of a state? A state is nothing but is a minimum set of state variables at a time t naught. If it is known along with input, then the entire control system behavior can be determined for future time t greater than t naught. That means if you know a state variable answer, if you know a state variable value at a particular time t naught, by using that and by using the input variable you can calculate the other parameters like velocity and acceleration you can calculate. And not only velocity and acceleration, you can calculate anything about the system. That is called as behavior of the system. So by knowing this state variable at one particular time t0, you can calculate the behavior of the system, okay, in future. That is called as state. So there is no much difference between state variable and state. The definitions you can write both as same only. Okay, so minimum required is what? Minimum you require y of t, then only from that you can calculate the velocity and you can calculate the acceleration, right? So the minimum requirement is what? Y of t. That minimum requirement is nothing but state variable. Okay, a state variable or a state is nothing but a minimum set of values which is required along with your input signal, so that you can calculate the other parameters of the system, or you can calculate the behavior of the given control system in future t greater than t0. So that is called as your state variable or a state. Okay, so now if I want to give one example of real time to understand state variable, consider you join to the first class in the first semester of engineering. Whenever you come and sit in any one of the place, many other students will come and sit next to you. So initially, because it is a first class, you don't know what are their behavior, correct? So first what you will do, in order to understand them, first you will ask some standard questions like what are your hobbies, where did you study, what do you do in your free time, like that and all you will ask. But then he will answer like my hobbies are playing games, watching movies and watching series, like that he will tell, playing cricket and all. So by his answers you will understand what is his behavior, whether he is a jovial type, whether he can play with you, or whether he can study with you. Like that you can analyze from his answer. So from his answer you will find out what is his behavior. Based on his behavior, in future, maybe after 1 year of your engineering, you can easily tell if you want to ask him to join you for a movie, then you can easily predict his answer, whether he will agree for coming to the movie or whether he will disagree for coming to the movie. If he is having a behavior of watching movies and playing games and jovial, then he will definitely agree for a movie. If he is always studying, a studious student, then he will definitely not agree for a movie, right? So after 1 year you can easily predict his answer. So if you know the behavior, if you know the standard state variables, here what are the state variables, what are his hobbies, what he will do in whenever he is having a free time. If you know all his hobbies and what he will do in his free time, all those things are state variables. Okay, so if you know the state variables, can you not calculate anything in the future? Okay, you can calculate. So the state variables are the minimum parameters which you want to know about the system. If you know those values, then you can calculate anything other parameters of the system in future. That is called as state variables for any control system. Now coming to the state vector. Assume that you have y1, y2, y3, etc. up to yn of t are your state variables. If you write all these state variables in a column vector, then you call that as a state vector. That's all. Now assume that you have only two state variables, y1 and y2, and if you draw like a x-axis, you take it as y1 of t, and y-axis you take it as y2 of t, and you draw, and whatever the graph comes inside y1 and y2, taking x and y axis, whatever the graph comes, that space you call it as state space. So state space is a diagram or the graph when you take the state variables as the axis. So here can you tell me it is how many dimension state space? Because you have only two variables, two state variables, you can call it as a 2-dimension 2D state space. Now, what are the advantages of state space? Previously, you can use the transfer function also to derive and design, analyze the control system. Now, why do you want this state space though you have transfer function method? Because the state space method can be applied for nonlinear systems, time invariant and time variant systems also you can apply. State variables method can be used for MIMO systems, multiple input, multiple output systems. Okay, whereas transfer function method can only be applied for a single input, single output systems. And state variable, state space method if you use, then the internal state of the system, what is the internal state of the system, that you can easily find out by using state space method. So these are some of the advantages of state space method over normal transfer function method. That is why you go for state space method. Wherever the modern control systems are there, wherever you go in NEAL or HAL, radar, satellite, wherever control system is used nowadays, in modern control systems, state space method is preferred compared to the old method, which is transfer function method. Okay, that is why the state space method is called as modern control system technique. Okay, so in all modern control systems, state space method will be used. Now assume that you have, now let us learn about state model. Model means you have to obtain a mathematical expression for a control system. Okay, assume that you have a single input, single output system. Okay, so consider you have a control system with single input and single output. Let me call u of t as the input signal and y of t as my output signal. Okay, remember I am changing the notation. Previously when I was explaining the introduction, I told y of t as a state variable. Okay, now I am changing the notation. U of t stands for input variable of the control system and y of t stands for output variable of the control system. Now let me call x1, x2, x3, xn are all your state variables. I am taking x as the state variable notation. Y means output, u means input signal. Now how many state variables are there? N number of state variables are there. x1 of t, x2 of t, x3 of t and xn of t. How many input? One input, one output. That is why it is called single input, single output SISO system. Now consider for this control system, let me assume a nth order differential equation. Let me assume a nth order differential equation. You know how a differential equation will be represented as, right? So consider this equation nth order. Nth order differential equation means d power n divided by dt power n into y of t plus a1. a1 is a constant. D power n minus 1 divided by dt power n minus 1 y of t plus a2 dn minus 2 y of t by dt n minus 2 plus etc up to an minus 1 dy of t by dt plus an y of t is equal to u of t. Where all y, wherever y I have written, that is nothing but your output signal, and is equal to on the right hand side u of t. U of t represents input signal. See, any control system can be represented like this, like a differential equation. In general, I am taking a nth order differential equation. Okay, LHS will be differentiation of your output signal, RHS will be your input signal. So any nth order control system differential equation will look like this. Okay, now for this, see, the equation looks very complicated. So what I am going to do, wherever d by dt is there, wherever d by dt y of t is there, I am going to write it as y power 1 or y dash. Dash represents what? Single differentiation. Wherever d square y of t by dt square is there, I am going to write it as y double dash. Instead of y double dash, I am going to call it as y power 2. Please understand, this is not y square, it is y power 2 double dash. Okay, y power double dash. Y power 2 is not y square, remember, it is 2 differentiation. The power 2 for y represents, it is double differentiation of y. Okay, if you have d cube y of t by dt cube, then I have to write it as y power 3. Power 3 represents 3 times differentiation of y of t. Okay, so here the power, whatever I am writing at the power, that does not mean it is a square or cube. It means how many number of differentiation. Okay, y power 1 means 1 differentiation, y power 2 means 2 differentiation. Now what happens to your above expression? Wherever d by dt is there, you write it as 1 differentiation or 2 differentiation, like that. So d power n can be written as y power n plus a1 into y power n minus 1 plus a2 into y power n minus 2 plus etc. up to an minus 1 into y power 1 differentiation, no, so y power 1 plus an into, there is no differentiation, so write down y as it is. Okay, instead of writing y of t everywhere, I am simply writing it as y. You should understand it is y of t only. Bracket t I am not writing, okay, to make it simpler. So plus an y of t is there, you write an y is equal to u of t, you write u of t. Call it as equation number 1. Now let us assume, till now I told you what is y output, what is input, u of t. Now I did not tell what is the meaning of state variable, correct? So I mean, what is the equation for state variable? That's why now let us assume x1 is equal to y. Okay, these are my assumptions only. In order to derive the equation, I am assuming like this. Okay, so let us assume x1 means what? First state variable, x2 second state variable, like that. So let us assume this x1 is nothing but y only, like that we will assume. So let us assume x1 is equal to y. Now let us assume x2 is equal to y dash. Y dash means single differentiation of y. Now y dash can be written as dy by dt. Now dy by dt can be written as, what is y? Y is nothing but x1. So I can write it as dx1 by dt. Correct, no? Now what is dx1 by dt? Dx1 by dt can also be written as x1 dot. See, if I write dot on the top of any letter, that dot represents a single differentiation. Okay, either you can use power 1, power 2, or you can use dot also. Is it clear? Either I can use power 1, power 2, power 3, or I can simply use dot, x power dot. Okay, dot means same thing as dash. Okay, this is one more notation for differentiation. Now let us assume x3. I assumed x1 as y, x2 as y power 1 and x3 as y power 2. Y power 2 means what? Double differentiation of y, d square y by dt square. So can I write d square y by dt square as dx2 of t by dt? Okay, because there are two differentiation. One differentiation means x2, one more differentiation means d by dt of x2, like this it will come. Okay, so dx2 by dt, and this dx2 by dt can be written as what? x2 dot. x2 dot means single differentiation of x2. Similarly, I keep assuming x4, x5, etc. Now what is the last assumption I can make? xn is equal to, xn will be equal to what? See, x1 is y, x2 is y power 1, x3 is y power 2. If you have 3, the power should be 2. Then what you should have? If you have n, then the power should be n minus 1. So xn is equal to y power n minus 1. What is y power n minus 1? d power n minus 1 y by dt power n minus 1. n minus 1 number of differentiations. So that can be written as what? dxn minus 1 by dt. Correct, no? For x3, differentiation of x2 you got. Similarly, for xn, differentiation of previous xn minus 1 you will get. That is equal to what you can write? xn minus 1 dot. xn minus 1 dot. Understood? Now I got x1 dot, x2 dot, xn minus 1 dot. How to get xn dot? I got from x1 dot to xn minus 1 dot. How to get xn dot? How to get xn dot? For that, what we will do, we will take, first we know that, what is that we know? Xn dot is nothing but differentiation, single differentiation of xn, correct? No, xn dot is nothing but single differentiation of xn, which can be written as y power n. How did I write this y power n? See here, x1 dot is nothing but y power 1, x2 dot is nothing but y power 2. Similarly, x3 dot is nothing but y power 3. So similarly, xn dot will be nothing but y power n. That's all. Okay. If you have x1, then you will get y1, x2, y2. Similarly, if you have xn, you will get y power n. So remember, xn dot is nothing but y power n. Okay. But I want to find out what is y power n. I have to convert it in terms of x. So you assume your equation 1. Take your equation 1 now. This is your equation 1. In your equation 1, wherever y is there, you substitute with x like that you substitute. So y power n, first y power n, I will substitute. You can substitute it as xn dot. Okay, that I am showing it in the next step. So for first step, keep y power n as it is, plus a1. What is y power n minus 1? Here, y power n minus 1 means xn. Correct? Y power n minus 1 means xn. That xn you substitute here, xn. Plus a2, y power n minus 2. What is y power n minus 2? The previous value. What is previous value of y power n minus 1? Y power n minus 2. That will be equal to xn minus 1. So xn minus 1. Plus etc. Plus an minus 1 you write down as it is. Y power 1. What is y power 1? x2. That x2 you write down here. Plus an. An you write down as it is. Y. What is y? Y is nothing but x1. That you write down. Is equal to u of t. Is equal to u of t. So I am converting my equation 1. Wherever y is there, I am converting that to x. As per my assumptions. Wherever y is there, convert it to x as per my assumptions. But keep the first y power n as it is. Now what is first y power n? This first y power n is nothing but x dot, xn dot. That I will substitute now. Y power n is nothing but xn dot is equal to. Send all the other terms to the right hand side. What happens if you send all the other terms to the right hand side? Plus a1 becomes minus a1 x1 xn. Plus a2 becomes minus a2 xn minus 1. All plus signs will become minus signs. Minus an minus 1 x2 minus an x1. And u of t will be u of t only, because u of t is already in right hand side. So u of t will be plus u of t only, no change. So xn dot is equal to all these entire terms is sent on the LHS. So that's why all positive terms will become negative after equality sign. Now what is the final expression I got? Xn dot is equal to, see, instead of writing xn minus 1 in a reverse way, let me write it first x1 and x2, n, x3, like that I will write. Okay, I will arrange it in the x1, x2, x3, like that I will arrange. So what happens? Xn dot is equal to, first I am writing this term, minus an x1, minus an minus 1 x2, second term, etc. up to last but one term is minus a2 xn minus 1. Last term is minus a1 x1. I am arranging it like x1, x2, like that I am arranging. That's all. Only rearranging the terms in the reverse way. Now at the last you have plus u of t. That you keep it as it is. Now whatever xn dot you need to find now, that xn dot is nothing but this big equation. Okay. Now we will see what happens in the next step. See, in the next step, now I will write down all those equations, whatever I have got till now, I will write down like this. x1 dot what we got? x2. x2 dot is equal to x3. x3 dot is x4, etc. up to, what is the expression we got for xn dot? The big expression. Minus an x1 minus an minus 1 x2 minus etc. minus a2 xn minus 1 minus a1 xn plus u of t. So these are the equations we got in the previous step, correct? I have simply written it once again. Now these equations are called as state equations of single input, single output system. Correct, no? Because we started the derivation from single input, single output systems only. So state equations of single input, single output systems. Now I don't want to write this expression like this. Let me convert this expressions into matrix form. So how to convert it into matrix form? On the left hand side, x1 dot, x2 dot, everything you have now up to xn dot. So write like matrix x1 dot, x2 dot, x3 dot, xn dot, like this. Okay. Now how to write the matrix form? See, in your matrix form, on this side I have written some zeros and ones. First we will understand how this zeros and ones came. So x1 dot is equal to what? x2. x2 dot is equal to x3. So first let me write x1, x2, x3, etc. up to xn. Now what is x1 dot? Which is equal to x2. x2 is present in the second element, no? That is why x1 dot should be only x2, and it should not be x1, x3. It should not come. So only x2 should come for x1 dot. First equation, right? That is why only for second element I am putting 1, and for others I am putting 0, 0, 0, 0. Okay, when you multiply this big matrix with this vector, you are going to get these equations. Now why did I write 1 for the third element? Because x2 dot is nothing but x3. x3 is present in the third element. That's why 0, 0. Third element should be 1, 0, 0, 0 for all others. So like that you will get fourth element 1 for x3 dot, because x3 dot is equal to x4. Fourth element should be 1. All others should be 0. Now what will be the expression for the last one? Last equation is xn dot is equal to x1 is also there, x2 is also there, all x values are there, but for x1 what is multiplied? Minus an. So first element should be multiplied by minus an. That's why minus an is written. Second element is minus an minus 1. So minus an minus 1. Third element will be minus an minus 2. So minus an minus 2, etc. What is the last element? Xn. Xn is the last element. Xn is multiplied by what? Minus a1. That should come as the last element, minus a1. So that is how this matrix is written. From this equation, this matrix is written. If you multiply this big matrix with this vector, you are going to get back the original matrix. Now why I have written plus something else? I am writing something else after plus. Why? Because do you have any plus term for x1 dot? No. For x2 dot you don't have any plus term. For x3 dot you don't have any term. For all x values till the last equation you don't have any plus term. Only for the last xn dot equation you have plus input, plus u of t. So for all x1, x2, x3 everything you put zeros. Only for the last value you should put it as 1. When you multiply this into u of t, 0, 0, 0, 0, only for the last equation you will get 1 into u of t, which is nothing but u of t. So you don't have u of t for all others. Only for last equation you have u of t. That is why only for the last element I am writing 1 into u of t. Clear? Okay, now coming to the number of rows and number of columns. How many number of rows are there? 1, 2, 3, etc. up to n. So there are n rows and 1 column. And here how many rows are there? There are n rows, n column. N rows, n column. N cross n. First number represents row, second number represents column. Now here how many rows are there? 1, 2, 3 up to n. N rows, 1 column. And here how many rows are there? N rows, 1 column. U of t. U of t is a single input now. Because it is single input, it is 1 row, 1 column. 1 cross 1. 1 cross 1 means only scalar. It is not a vector, it is a scalar. Now I don't want to write this big expression. So let me convert this x1 dot, x2 dot, etc. up to xn dot. This I am going to convert it as capital X dot of t. What is capital X of t? Capital X dot of t. Inside that this will be there. Okay. This I am calling it as capital X dot of t is equal to this big matrix whatever is there, that I am calling it as capital A. And this matrix I am calling it as x1, x2, x3. I am calling it as capital X of t. This is only x of t, this is x dot of t. Plus this whatever the matrix I am writing here, 0, 0, 0, last one, that I am calling it as B, capital B. And this u of t I am writing as it is. So what is the expression we got? X dot of t is equal to a x of t plus b u of t. Okay, I call it as equation number 2. Now we know that y is equal to x1. Correct? How we know y is equal to x1? We have derived it in our previous equation. See here. In the beginning of the derivation, we assumed x1 is equal to y. That means y is equal to x1. That only we are taking it here. Y is equal to x1. So if y is equal to x1 can be written as y of t is equal to, y means y of t only, 1 0 0 0 0 0. Why I am writing 1 for the first element? Because x1 should come. x1 will be present in the first element only. That is why my first element is kept as 1. And I don't want other than x1, I don't want any other x2, x3. So I put 0 0 0 0 for all other values. Only for first element x1 I am putting 1. So if you multiply this row vector with this column vector, you are going to get back this y is equal to x1. Correct, no? First row into first column, if you multiply 1 into x1 plus 0 into x2 plus 0 into x3, all are zeros. So what is the answer you will get? X1 only. So this y is equal to x1 can be written like a matrix equation. So call this 1 0 0 0, call it as another matrix C, and call this x1, x2, x3, xn. What is that? x1, x2, x3, xn. I took it as capital X. Same thing you take here also. x1, x2, x3, x1, you take it as capital X of t. Okay, so now what is that? I got y of t is equal to capital C, some vector into x of t. Call it as equation 3. Okay, now this sizes I am writing 1 row, n columns. Here it is n row, 1 column. Now if you multiply 1 cross n and n cross 1, you are definitely going to get 1 cross 1. So 1 cross 1. Why you got y of t as 1 cross 1? Because y of t is a output signal. How many output signals are there? 1. That is why you got y of t as a 1 cross 1 scalar. Now this equation 2 and equation 3 are called as state model of, these equations 2 and 3 are called as state model of single input single output system, SISO system. This derivation will be asked. Derive the expression for state model of single input single output system. For 6 or 8 marks they can ask the derivation. So this is the important derivation. Equation 2 and 3 are called as state model for SISO system. Now what is the derivation? What is the expression for MIMO system? Multiple input multiple output system. There is no derivation for that. Straight away we will remember the equation. So state model for MIMO system. Your MIMO system looks like this, no? One control system, U1, U2, U3, UM. There are other than one input, there are so many inputs you have. Okay, m number of inputs are there, and capital U of t contains U1, U2, U3, etc. up to UM. And assume instead of one output you have P number of outputs present, Y1, Y2, Y3, etc. up to YP. Okay, multiple inputs, multiple outputs. What is the size of the input? M rows, 1 column. What is the size of the output? Y of t, P rows and 1 column. M is the number of inputs, P is the number of outputs. And assume that you are going to get n number of state variables. Okay, I don't know how many state variables you will get. So assume that you are going to get n number of state variables. x1, x2, etc. up to xn are the state variables. Now, what is the state model equation? You need not derive anything. Directly write this expression, 2 expressions. Okay, x dot of t is equal to a x of t plus b u of t. You got the same expression for SISO system also. So I'll get the same expression. Write the same expression. Now, what is one more expression? Y of t is equal to capital C into x of t plus d into u of t. Okay, did you get the same expression for SISO? No, only you got y of t is equal to c into x of t. du of t you did not get for SISO system. But for now MIMO system you will get d into u of t also. Now this derivation is not there. Directly you have to remember the equation for the multiple input multiple output control system. Now see the sizes. The capital A is called state matrix. This is the name given for capital A. In wherever future numerical problems, wherever they mention state matrix, you have to understand it is nothing but capital A. Capital A is state matrix, capital B is input matrix, capital C means output matrix, capital D means transmission matrix. These are just the names given for A, B, C, D matrices and vectors. Okay, now the sizes I have written. You know u of t, previously I wrote 1 cross 1 for SISO, but u of t for multiple input is m cross 1. M means number of inputs. And previously for y of t also I wrote 1 cross 1, but now I am writing p cross 1. P represents number of output signals. That's why I am writing p cross 1 for y of t. Capital Y of t. Inside capital Y of t what will be there? y1, small y1, small y2, small y3, like that. Inside capital U of t what will be there? Small u1, small u2, small u3, small um, like that. So this is the expression for state model for multiple input multiple output system. Now can we write a block diagram for state space model for a multiple input multiple output system? So I have to write a block diagram for MIMO state space model. By using these two equations, I have written this block diagram for MIMO systems. How I am writing this block diagram? First take u of t. See, this u of t is multiplied by b, no? That's why I am multiplying u of t with b. After multiplying, what you should do, b into u of t should be added with a into x of t. Okay, you don't know where is a into x of t coming. So assume this, there is one line a into x of t here. Okay, you don't know what is its previous. Later I will tell this. So b into x of t is added with a into x of t. How a x of t comes, I will tell later. So after adding b into u of t with a into x of t, what is that you will get after adding x dot of t. So after adding these two, you will get x dot of t. So what you have to do for x dot of t to get x of t? X dot represents differentiation. If you want to remove differentiation, what you should do? Integration. So for x dot of t, send it to a integrator block. What this integrator block will do? It will remove the differentiation, dot will go, and then you are left with output of the integrator will be only x of t. Now this x of t is ready. How to get a into x of t? Take that x of t, multiply x of t with a matrix, then you are going to get a into x of t. So it forms like a feedback loop, correct? No? Okay, without this x dot cannot come, and without x dot this x cannot come. So it will be like a feedback loop. Understood? Now once this x of t is ready, for x of t how to multiply? C. So multiply x of t with c. After multiplying x of t with c, you have to add that with, you have to take a summer and add it with d into u of t. U of t is present here. For that you have to multiply d. So for u of t you multiply d, and after multiplying you will get d into u of t. That d into u of t you add it to c into x of t. After adding d into u of t with c into x of t, what is that you are going to get? Y of t. So after adding you are going to get y of t. Y of t is what? Output of the control system. And u of t means input of the control system. X means it is the intermediate variable. That is why it is called state variable. X means state variable. U means input signal. Y means output signal. X means state variables. That means the intermediate variables. That is why x is used in the intermediate variables. And why instead of using a single arrow mark, single line, why I am using like a double line for arrow marks? Because u of t is a vector. It is not a single line. It is not a single input. U of t contains u1, u2, u3, etc. up to um, because it is a MIMO system. That is why it is not a single variable, it is a vector. That is why I am using double arrow marks, double line arrow marks everywhere. Understood why I am using double line arrow marks everywhere? Because of u of t and y of t is a multiple input, multiple output system. So this is the block diagram for MIMO state space model.